Well, he is presently working as technical lead for Thales Group for R&D team India. Prior to this engagement, he was associated with Xilinx India, Perfect VIP Techno Solution. Well, in terms of academics, he hold a doctoral degree in research area of computer arithmetic and computer architecture. Well, he has published more than 10 research articles in reputed journals like IET, Elsevier, World Scientific, AMSC, and etc. He also holds additional responsibility of contributing as journal reviewer for many publication houses. So without any further delay, ladies and gentlemen, I'd like to request Dr. Bari to continue with the session. Sir, please.
Yeah, thank you. Thank you for this warm welcome. Just to confirm you one more time, like, am I audible right correctly?
Yes, sir. Yes, sir.
Yes.
Audible.
Okay. Yeah. Thank you. Thank you all for this attendance, and also I would thank GIT for this opportunity. To provide some this opportunity to start with, and this is a kind of a giving back to the academic what we learned during my academic years as well, and what we are learning right now in the industry. So thank you one more time. Let me share my screen. Okay. uh, Let me know, anyone can see right my screen?
Yes, sir. It is visible.
Yes. Okay, thank you. Okay, so this is my topic of discussion today: latest research and technological development for SOC application. So before jumping into the topic, I'll start 2 minutes of time for to give you the brief introduction on the what I'm, which company I'm working on, and what is the activity that probably this particular Thales provides us. So just to give you the brief, quick overview. So we are around 81,000 of employee across the globe. We have like 68 country. We are into the ground transportation, space, aerospace, defense, also in the digital identity security. So the number itself is a big. And in terms of the research, we are spending more than 1 billion means like euro per year in terms of R&D. And over the last 5 years, we are already spent more than 7 billion. So it's itself a big number for us. And as compared to the other research and funding agency. So coming back to the Thales in India, we are headquartered in Noida right now. We are in Delhi, Nagpur, Mumbai, Pune, Hyderabad, Bengaluru, Chennai. So in the engineering center that we are having, there are two engineering center, in the Noida and Gurgaon. One engineering center that is mostly dealing with the digital identity security, and the second one, I am part of this engineering center, Bengaluru, that is morely towards the aerospace domain and the transportation defense. Also, we have a R&D group that who is dealing with some kind of innovation work along with some kind of development. So in terms of academic collaboration, we are collaborated with the IIT Delhi, Mumbai, Madras. Also, we are associated with the Indian Institute of Science in Bangalore. Also, some kind of triple IT are coming into the collaboration part. So, in terms of civil aerospace, we are into Indigo, also the Air India. Also, we are associated with the Airport Authority of India. So, I'm not going brief about this. Also, we are associated with this Air Force and Navy Army of India. So this is the brief, and we are since 1953 we are here in India. So this is the brief discussion of the Thales, and let's jump to the topic that latest research and technological development. And basically, I'm focusing on the SoC application, not the IP application. So, what is the motivation that we are dragging for this topic of is like why the semiconductor engineer are always in demand? That is the first question that I can ask to all of you. Like because we are dealing with different technology and we are dealing with very state of art technology also in the methodology that we are following. So it's hard to find a good engineer which has the capability of dealing with all this technology and innovation uh, throughout the market study. So in terms of design as well as in terms of verification, it's very hard to get those outsourcing and flexible engineer because someone means like not ready to change this domain, his domain or like the activity that they are already involved with, so they are not going to change those. So it is very hard to find those engineer. And also not only for the engineer, it is also for the faculty member, so we can in line with the research activity or development activity that industry is following, that also we can follow in the academic part. So it's both the side effect, like the faculty member as well as for the student, they can deal with the research and activity what state of our technology is doing in the semiconductor field. So I'll be focusing on more towards the digital side of the means like electronics, not the analog side. So that is the thing. So coming back to the means like where we are starting with in terms of BLSI, we are already known about the Moore's law, right? Like within 18 months, the all the transistor side and getting double. So this is the impact to the BLSI industry from the last couple of decades, and still it is there, but it is almost in the peak level for now. And if you see the abstraction level in the VLSI thing, starting from the device level to the system level, we have different circuit architecture, algorithm, all these abstraction level we have. And like if you see all these DB engineer, the design and also the verification engineer has to deal with different parameter. That may be the your threshold reduction, that may be your leakage power, the complexity, that latency, performance, all this stuff he has to deal with, right? And that's why that means like area of the area in the VLSI is vast. So he has to deal with the different instruction set level, command level, all this level he has to deal with. So that's why the getting into a getting a experience and also like the capable engineer who is flexible enough to deal with all this sort of technology, it's hard to find. And also it is very much important for the faculty member to deal with all this activity in terms of research and development. So that is the motivation, and this is the BLSA flow that we are already aware of, right? Starting from the specification to the FPGA level, or in the left hand side it is the FPGA level, and in the right hand side it is the GDS. So I'm not going into the details of it, but what I will say, like in each level of this particular starting from the specification to the RTL discussion to the functionality, the functional coverage, synthesis, all this stuff is itself a R&D work and itself a innovation work that we are coming up. So in this is the FPGA side. In terms of RTL ASIC level up side, also we have different sort of activity like floor plan, the flower plan, cell flashing, and all this stuff are there. And if you see all this activity are also there, it's like in terms of R&D work, in terms of development work. So coming to the what is the industrial impact we are having right now. So if you see like we are into the era of automatic vehicle, the smart city, the internet of things, machine learning, all this stuff we are already developed in terms of means like design, in terms of the development. But if you see means like your mobile smart device is there, and once the internet is on for your device, then it's almost connected to the million and billion device across the globe. And it contains like your personal data in terms of your bank account, starting from your bank accounts to your location, your images and everything. And so this ecosystem has to be the protected one. Means like it has to be the verified in terms of security. It has to verify in terms of malicious threat attack, whatever people are trying to hack the system. So all this ecosystem has to be verified properly and has to be secure enough so that it can be no issue with the market level. Okay, so this is the industrial impact. Right now we are already far ahead in the innovation in terms of design, but in the we are lacking behind in the verification thing. We were lacking behind in terms of like how we can make stable those ecosystem. Okay, so that is the impact we have right now. And if you see, means like what is a typical microprocessor in the 2 decade ahead or one means like 3 decade ahead. uh, we have the life cycle, means like we had the life cycle for 2 to 3 years, or we can say 3 to 4 years based on the features. But nowadays it is shrinked to means like roughly 6 months and so. So if you can consider one example, your means like the processor that you are having in your mobile. So in those mobile, like let's suppose today you have the 650 Snapdragon, then in the next 6 months it may get upgraded to the 850, and you'll start feeling like that you are holding a old mobile and old processor mobile, right? So this life cycle has decreased enough so that we are not getting enough time for the market to verify all this stuff, like your camera IP, the sensor, the analog domain of the research. They are developing their own features, and we are not up to the mark to make in line with the both the activity in terms of design as well as in terms of the verification. Both the stuff are not in line right now. So this aggressive shrinkage that we are having, so that is making means like the it's making a possibility of this kind of hacking or this kind of links like lacking behind the specification that what we are up to the mark. Hello. Okay. So that is the thing that we are lacking behind in terms of innovation, also in terms of the verification side. So what is the industrial approach that we are currently following is like we are, if we consider the SOC level, then it consists of the different IP, different intellectual property. So let's suppose we have the different IP in terms of hardware oscillator. We have DSP, CPU, the core itself, the custom logic that we are building for the our need. So each and every IP are getting means like developed and getting verified based on the means like their own features, and then we are integrating with them in terms of SOC, or that may be the subsystem level, and then we are verifying it. So this is the one approach that typically the industry follow for the whole SOC level of verification, but it takes some time. Like we have to connect all the buses, we have to integrate all those things in some kind of ARM protocol or some kind of communication protocol, and then it has to get verified. So it takes a lot of time, and like when we are dealing with some kind of means like new features addition in smaller time, then it is not that much efficient. So this is the one drawbacks that we can say that what current industrial approach. So if you see like what is the advantage, till now I have discussed with the negative side of this thing, like we are not in line with the what the design side we are doing. We are adding the features, and we were not coming up to the mark of the verification side. So what is the positive side? Like we have not given a importance to this verification, but what is the consequence is around like this sort of like negativity, or this sort of like lacking, it's dragging all the community, the verification community, as well as for the who are dealing with all this industry for the last some decade. They are coming up group, and they are dealing with all this stuff, that how they can use this all this experience, and they can build up the industrial verification, new intelligent verification environment, or the smart verification strategy, that how they can build up, and how they can leverage the use or leverage the work of a verification engineer, or it also affect to the design verification engineer. So this is the one positive side. We are coming up with a intelligent, very smart intelligent system, uh, or ecosystem, I can say. So there we can easily leverage our time or easily leverage our means like effort that what we are doing for the verification domain. So this is one positive side of this. So we are already known like means like the Verilog and BSDL are there in the language part. Like what is the in terms of the hardware design we have already known, but in terms of the verification, like the concept of the class based, the OOPS concept, then the association based, the coverage based, all this they are coming up with a all these features and they are dragging into a single language that is known as the system Verilog language, SB, that we are calling it. And most of the industry right now is following this language, particularly for the verification at least. Also some of the industry are also following this system Verilog for their design approach. So we are coming up with some kind of features that already is there, but we are making in a single platform, and we are leverage the time effort that we are doing for the verification or the design aspect. So that we are coming up. So only the language is not the solution. So what we can do, like we can create a methodology, like how to deal with the situation that creates a method we can create. And like right now we are dealing with the UVM, so universal verification methodology that we are calling it. So most of the industry in the market are following the UVM, or at least they are following the OVM. So these are the methodology. So what is this methodology is like, it creates a ecosystem already to you, and you can add your features. So it can leverage your time. So that is the um, main goal of this particular area of R&D or area of development. So what is this UVM? Let's give a brief introduction for this UVM. So let's suppose we have to deal or we have to create a digital circuit. So we are given with some kind of logic gates, that may be the AND gate, OR gate, or XOR gate, NOR gate kind of thing. So it is providing us a digital library, and through that gates we are creating our own digital circuit, right? So that is the same concept we can apply here in the UVM. It provides us a kind of reference manual or the reference of class. So it, whenever we are generating some kind of stimulus, it provides us a component. Whenever we are dealing with some kind of checking mechanism, it provides us a kind of checking component. So already predefined classes are there, and just to we have to develop those and we have to use in our own ecosystem or own environment. So this is the basic description for this UVM, like universal verification methodology, that it provides a class of reference which we can use in our own verification environment. So that is the need of this methodology. And most importantly, this particular methodology use the concept of system Verilog. So once the system Verilog language is means like uh, it's done for this, like we can develop our own environment in the UVM framework. So this is the thing. And the main advantage along with this, it provides us a very basic advantage like that. Like whenever we are dealing with different kind of IP, we want to reuse it, like in the next version of some kind of SoC, we want to reuse it. And how we can reuse it? Using the framework of this UVM. So let's suppose we have to generate the similar kind of stimulus, we have to generate similar type of protocol checking mechanism or scoreboard mechanism. So similar IP, the component, we can use it, and we can develop our own environment in a very quick time. So that is the uses of the and also we can reuse those things in our next level of or next iteration of verification approach. So it is also means like leveraging our time for that, how quickly we can come up with the market solution. And also whenever we are dealing with the SoC, the similar approach that we have already previously followed for the SoC level, so similar isolated environment or item we can pick up from those environment, and we can go for the SoC level of verification in the next iteration also. So the concept of reusability is coming to the picture using this UVM framework. So this is the one biggest advantage that we come up and we help the verification engineer through this development. So this is the typical structure that I can provide you, or how the normal framework of this UBM works. So let's suppose this blue section provides us a duty, design under test, and it has some features, it has some specification around it. And to verify those features, we have to give some stimulus. This is the left hand side. What I'm pointing, that is a stimulus, and through this stimulus, it generates the data, right? So this mechanism, like the to provide a stimulus, the UVM framework provides us a generator class. This transmission of the stimulus to this propagation to the output, that is deal with the some kind of class library. And also whenever we are comparing this thing, like this output has to be compared with the actual data, that what is has to be output based on the specification, that has to be a comparison mechanism or checking mechanism in terms of scoreboard or something. So that is also provided by the UVM through the some kind of scoreboard component or the checker component. So all this framework is already present, but based on these features, that what we are trying to deal with this for the duty, that we have to deal with, and that we have to write the code or write to develop the code. Or similar, in case in the next iteration we need this sort of environment again, then we can also reuse this environment or the ecosystem. So this is the basic mechanism, that how we can find a bug or how we can verify a system through this environment building approach, using the system Verilog as well as using the UVM. So this is the mechanism. And this is the bigger picture that you can consider. So this, the black person, is the duty. It contains the cache, it contains the CPU, it contains the physical memory, virtual memory, and all stuff. In larger framework of the UVM, we have to deal with all the component. This section is known as the component. It's connected to the interface, the driver, sequencer, the monitor, the configuration, all this stuff are there. And we consider as a IP also. This is the IP, this is the VIP, means like verification IP that we can consider. And along with this, we have the system ecosystem of scoreboard, the checking mechanism, and all this stuff. And also the register model to check this registers, CSR, and all this stuff for the core. This configuration register are there. And like how we can deal with different memory model, or like how we can deal with some kind of virtual memories, that also it provides us. So along with this, it provides the coverage part, like how much percentage we covered for the verification. So normally the in terms of design aspect, like we have the code coverage kind of thing, which tools like your maybe the VCS tool or Cadence tool that normally people are using. So that provides that the tool itself provides that how much code coverage has done. But this framework provides us the functional coverage. So what is the functionality of that particular DUT has covered, that provides us in this framework. So that is the one thing. And we can whenever we are selling for the market and we are going for the market, then we can say like that this is 100% coverage is achieved for this verification. So that is big advantage in this domain. Coming back to the next topic that I can discuss with, that how in FPGA framework we are dealing with. So we know like in FPGA hardware, like these are the process starting with some kind of code based on the specification. We just expand the code in terms of the netlist. We optimize those netlist based on some kind of optimized algorithm or the hardware installation kind of thing. And then we go for the place and route, and then we can generate the bit stream and we can dump into the FPGA. So this is the normal procedure we follow, and based on the elaboration, compilation, and synthesis, and the floor planning that we have in the in terms of Vivado or the Costa, it's like Intel tools. So all these things are there. But when we are dealing with the SoC in FPGA, it's hard to debug any kind of bug. So let's suppose we have a SoC here. Let's suppose we have a SoC, like this is the netlist that contains for the SoC, and it is a FPGA device, and this is a schematic diagram that we are having. So in this case, like let's suppose this pointing, it is pointing to a one bug here. Some kind of issue is there in the FPGA itself. So how we can make debug this particular thing and how we can know that what is the issue here. So it is very hard to define if we are dealing with the SOC directly. So what we are doing here, like this is the new approach that Xilinx is mostly providing. Like in this case, like we are coming up with a prune chip approach. So these all are the SOC. These all are the SOC, and let's suppose this is the bug area. So this is the one IP area that we are defining, and here how we can prune it out. Like let's suppose this is the bit, right? Like the output of the is like the APG flow is the bit file, the binary file. So how we can prune it out and we can differentiate this particular block. So this is the process, in the verification process we follow, and we differentiate this process, this particular block through this it's like the SOC level, and then we can go for the simulation of it. So this is the normal process. What are the bits are associated for this particular IP that we differentiate through the coding method, and then configuration of that FPGA again it is done, and then we can go for the simulation. So rather than finding a bug in the SOC level, finding a bug in the FP level is much more easier. So this is the approach in pruning out, and we are calling it as a port FPGA method of verification or the finding a bug. So this is one approach that Xilinx is mostly following, and it is really helpful for them to finding a bug. So coming back to the UVM thing again, uh, so we are means like we know like what is the advantage that we have already discussed, that what UVM provides us in terms of uh, like like the reusability in terms of the class-based reference and all this stuff, but also it provides a unified area of like the simulator. Normally in the industry we follow the BCS, Quastar Sim or Celium. All these are well acquainted with this IEEE manual what UVM provides us and the class-based library. But what is the main limitation I can say in the UVM? So it is very much difficult for a means like unexperienced engineer to start with the UVM framework, and it is provides a vast area of means like class-based reference. So it is not that much feasible for a newbie in the industry to follow this UVM. And also it provides unified a limitation when we are dealing with different sort of subsystem level. So I'll be discussing on that part. uh, so this is the advantage that we have discussed, but there is certainly some kind of limitation as well. So when we are dealing with kind of it's like a larger SOC, then we have to deal with some kind of configuration, some kind of data packet. So there, how we can verify one thing, and whenever we are finding any bug or we have to debug something in terms of like we have to deal with some kind of issue, there we have to isolate those things. We have to isolate those layer, like what are the means like configuration that we are giving to the channel, how the memory size are affecting to different kind of isolation, and how the data pattern, like let's suppose we are dealing with some kind of communication protocol, APB, AXI or so. So how we can differentiate those things and how we can send those data, like we have discussed how the generator component works in the UBM. So we have to differentiate those things and we have to isolate those things, then only we can go for a debug, right? And the timing issue and all these things. So but this is very much difficult that in a SOC level we have to differentiate, and we have to differentiate the or isolate the layer. So and it is not that much easy task, or the not expected task for the any kind of team. So it is not that easy. So how we can deal with this issue is through one another approach that we follow, that is the PSS, portable stimulus. So it provides us a single representation stimulus, where it provides a test scenario where it is feasible for the all the level of the subsystem level. So so this picture will be useful for understanding, like how this UVM works is like it provides a UVM based class reference manual, right? So let's suppose these are the three subsystem level that we are dealing with, and we are creating a SOC for this particular. Uh, so this is one framework that I can say. But this sort of subsystem provides or takes the input in different configuration. The second subsystem takes the input in different configuration, and so on for the third one. So this PSS provide us a unified and a similar stimulus, and it can be the configuration based the hierarchy that we can provide through this PSS, so that the lower hierarchy that we are dealing with, that will be remain in the UVM, but the upper hierarchy that we are dealing with, that will be a unified version. So that is the one disadvantage that we can say in the UVM that we discussed just now, that can be solved through the PSS. So that is one. So this is mainly used whenever we are dealing with different subsystem level, and later we have to add those subsystem level into the SOCs level. But in IP level and subsystem level solely, then the UVM is the best way to go for the verification. So this is the one thing. And to give you the more details on this, this picture will be useful. Like, see, in this case we have a sequence, the driver and means like all this stuff are there. And this lower hierarchy for the means like all the subsystem level, it is the component base of the UVM and rather than the PSS. But when the configuration stage, the sequence library and the test sequence are coming to the picture, and when it is coming to the SOC level of verification through the stimulus providing, then it is deal with the PSS. So this will be not be any change to this lower hierarchy. The only thing that it will change with the means like the higher hierarchy that we are dealing with. So this is the one thing that industry are getting approached with. And most of the industry, whenever going with the SOC, that they are giving a standard PSS for this. So basically we can say like that whenever we are dealing with some hardware as well as for the software approach, then we can use this UVM framework as well as for the PSS approach. So this is the point. Then coming to the next topic of research area that I'm part of in current employee. This is the recent trend that it is going with the open hardware development. Basically, I am also part of this open hardware group, and the Thales is providing means like trying to build away the processor using this ISA. So we'll discuss on this particular means like development approach. So Rixby is nothing but it started with a 3-month project, right? These are the founder inventor for this Rixby, and it provides us a ISA. Which means like instruction set architecture that we can say. So we have many commercial ISA in the market, like AMD provides, or ARM provides, or Intel provides, or 86s. But those are like the having some license issue that the normal people or the university level of faculty, they don't use it. Though can use it because of the license issue, and we have to provide we have to give a very high amount of money for that IP license. Okay, so this is started with a 3-month project as for their MTech project and PhD project, and they provide a simple ISA, seeing all the demerit and all this stuff in what ARM and the Intel provide us right now, because they have far ahead with this thing, and they can change whatever they have done in the recent, the last decade, what they upgraded their ISA in terms of Intel and in terms of ARM. So this is the advantage is here. This particular ISA, like it's license free, there is no loyalty for this particular one. And there is a group, Rixby Foundation group is there. They are maintaining this particular ISA for this the specification in terms of privilege specification, in terms of debug specification, or the normal ISA specification. So that is there is no company for this particular ISA. They are just maintaining this ISA as a specification, and we as a engineer, or we as a company, like we can use it and we can develop our own core. So many university in the recently we have seen like the Sakti processor in IIT Chennai. They have used this ISA as well, and they have developed for the Sakti processor. And like starting from the small microcontroller to the supercomputer, we can use it for this particular ISA. Sorry. uh, and the most important thing is that we can upgrade this ISA based on our own feature. So someone is coming with some kind of innovative means like idea or innovative core development area, so they can use this particular ISA and they can use their own sort of ISA and use this and it can develop the core and they can build up a processor out of it. So this is the main area of research throughout the Europe and throughout the UK. It is going on. China is also ahead in their building. Also there is a company like you must be hearing like SciPi is there. They are building their own board using this ISA. So if you see the what are the company in the industry, almost all the company are there, starting from the Intel, Qualcomm, Thales, Rixby, SciPi. Every company are there and they are using in different sort of, because see, whenever we are dealing with any kind of processor, we have to deal with like ARM, or we have to deal with Intel for their processor and their uh, license. But whenever this ISA is free, they can use their own ISA in terms of features, and they can build their own like uh, core out of it. So that is the main advantage that we are getting. And the very much like this is the ETH Zurich. It is starting point for this processor that we are dealing with right now. And these are the university, different university, they are dealing with this particular ISA. So what is the advantage and what is the why it is so important for the researcher and development right now? Because see, if you see the software market, if I can compare the Windows and the Linux, Windows is in terms of the license side, but Linux is the free version. That's why we have so much progress in the Linux side. Almost all industry follow the Linux, like in terms of Red Hat or in terms of Ubuntu or all this different version of the Linux. So this is similar approach that Europe is trying to go for the hardware domain, not only for the software domain, also for the hardware domain. So Europe is much more active in making all this platform open, and like in terms starting from the application layer to the hardware layer, they are trying to build the cloud-based IoT based on this ISA as well. So it will be open for all, and the development can be so faster what we have achieved till now. So this is one area that mostly the Europe is trying to get familiar with, also along with the China. So see, if in case of this picture, you can see the OS compiler tools, the scheduler library, and application. All these are the open, almost open. The only thing that we have to deal with the hardware system, which is some kind of IP that we can consider, and those IP are some of the IP are the open, but not all. But if you see the CPU, GPU, and ASIC, all are closed only, because this is mainly dealing with this all ISA, which is provided by the licensed version, like Intel or what ARM is providing for them. So this is the, if once someone is coming through the Rigsby processor or Rigsby domain of the ISA, then this can be also a open thing for all. So starting from the application layer to the CPU or GPU level of thing, we can make it open. So this is the one biggest area of research right now in is going on, and the some of the faculty member in the India as well are so dealing with this sort of research area. So basically, to give you the brief how normally a processor work and how we can use this ISA in this framework, there are different pipelining approach, that may be the two pipelining or pipelining. This sort of picture is the pipe number of pipelining we are dealing with. So the first one is the instruction page, the decode, the execution stage, the memory, and write back. So to give you the what is where the we are using this ISR. So this is already there. This is a normal sort of architecture. This is the based on the computer architecture academic. But this command that what the program counter is taking, this is done through the ISR itself. So then it will paste the data from the that may be the instruction set, that may be some command, or that may be the data itself from the memory. So it will paste this instruction through, and it will go for the execution in this page, and decode it, and then you go for the execution of this set. The starting point is the ISA itself. So how we are going for the coding structure of this processor, that is truly dependent and truly important for the ISA itself, which ISA we are going to use. And this RIXP provides us a pre-ISA, which is available further and also organized. And most importantly, that we can reuse it and we can extend it according to our own uses. So this sort of processor is more into the research area, into the development area, and all the company are like or the faculty member are keen for this particular research area, because they can use their own features and they can go for some patent out of it, or they can go for some kind of publication out of it. So this is one area of development that is going on. And just to summarize, like this is license free. It is accessible for the IoT, then rapid maturity, because this is the open hardware group is controlling this thing. So means like at a time some more engineer means like across the group can work on this particular core or development approach. So this is maturity is rapid, and the open standard controlled by the RISC organization itself. Security, because security is the key in features that I have already mentioned in initial discussion. Uh, you can increase the security based on the encryption mechanism, and that is those the license free version of this. This is the license free version. We can create our own encryption and decryption algorithm here, and that's why this particular it's like architecture are more secure as compared to the license version, because we are not seeing or we are not able to capitalize those encryption and decryption algorithm inside this computer architecture, what is there in the commercial tools, commercial ISA that provides us. So this is the advantage, and this is the summary that RISC provide us. So what is current activity that is coming up, and what is the research activity that we can be part of right now? See, there is a lot of development. See, what I discuss here in the development of the core, that is already there, and like some of the university, they have developed their 2-stage learning or 5-stage learning. All this architecture is already there, and you can easily find in GitHub or the GitLab. But the main approach is that those, as I discussed, we are already far ahead with the design activity, but we are not far ahead or the inline with the verification activity in terms of different area of development. So this is also one area that we have far ahead in the design activity, but in terms of verification, we are lacking. So this is the approach. The all the across the globe, starting from the Google itself, it's taking the initiative, and it's creating a universal framework in the verification thing. Uh, it's like using the concept of system verilog, using the concept of UVM, and it's trying to get familiar with the verification environment for all the who are building those core. And what it's providing, just to brief you the means like picture that what I am showing right now, this providing a random instruction set generator. So this instruction set provides this particular ISA in the randomized manner, what features that we are going to use for this core. And this is developed by the Google itself. So we are calling it as a RIXB-DB. We are calling as a RIXB-DB. And like here in the assembly program, like it is generating a test program out of it. And then there will be compiler. So this compiler will generate all this assembly language program to a binary value. So this binary value means like those the output is the converted to the hexadecimal, means like this is the binary value is dumped into the memory of a core. So normally the core deals with the memory, because it has to take, because in this case you can see it has to face the instruction, it has to face the instruction as well as it has to face the data, right? So here this memory is dumped into this core memory of this memory of the core, and then the instruction process followed and some kind of verification mechanism. So we are trying to come up with some kind of verification framework, and all the means like starting from the Google, as I mentioned, it is trying to develop those UVM framework out of it. So the coding language will be the system Verilog, and the complete environment starting from the Rigsby DB tools to this comparison mechanism in Impress, that will be done in the UVM. So I'm provided some kind of links where you can get some kind of core. See, even as I mentioned, like that we are far ahead with the core development. So we have E40P, CBS6, 40X, 40S. All these core are already there in the open hardware, but we are still trying to develop some kind of verification environment, and how we can make it work for this core development using the Rigsby ISR. So this is the recent development that we can participate in the open hardware as well as for the own development, because this provides us a pre license for the development approach. But whenever we are ready for any kind of development, we can patent it our own. So this is the good thing for the any kind of research area that faculty can take up, also along with the students. Okay, so thank you, thank you for all your time. This is any question from the audience?
Thank you, sir. I'd like to request our audience to kindly put up any questions, if any. They can directly ask, or they can put their questions in the chat box. Dear audience, do you have any queries?
Dr. Barik, I am Sasank here. So
Hi, sir.
one question from my side regarding the particular as an industry person. So how our faculty or our research scholars can collaborate, can how they will link with the industry so that they can avail the facilities or they can learn something so that it will be implement the particular student point of view, or they can implement in their life, or they can simply we can say that how they will enter the industry.
Okay. See, first of all, like this is the area that we have to work in, particularly in India, because I'm dealing with the IIT Madras, also ETS Zurich in France University. So what I can see, like they are already ahead with this collaboration tasks, because what they are learning in the university, they are already the technology that we are learning in the industry. So they are already ahead. But here we are, what we have to do is that we have to change our curriculum first of all, what is feasible for the industry and what is feasible for the students to take care, means like the next step in the university, in the industry. And what I would say, like the faculty can take care of this thing, and also the in terms of research area. So what we are seeing, like I can give you one example. Recently, Triple IT Delhi is going to collaborate with us in the Thales India. So here, how they have maintained this repo is like they have keep on doing research in the NOC level of multi-core level of research, and they showed us like that how much they have it's like they have the interest in the core area of research. And then we can show up, they can show up that this many research they have done, and we are ready for the collaboration. And there will be a positive side from our side as well, as an industry, so that we can also see like that they have this many number of research publication in this area, and we can get some kind of positive feedback out of them. So that is the thing. And in terms of student, I can say start learning on the technology, new technology, connect with the means like experience means like engineer alumni, and try to get some kind of knowledge like which area or which research area they are doing right now, working right now, and there they can brush up their knowledge.
Okay, thank you. And
Yeah.
Dr. Barik, can you go for a MOU in your particular, like we can say that your institute with the academy? Is this possible through your
Yes,
organization?
definitely it is possible. As I mentioned, like recently, only 2 days back or so, Triple IT Delhi is going for some kind of AMU for us, and previously we are already there with some kind of IIT Delhi and Madras. But as I mentioned, like that, before going for AMU, means like from the university level, the faculty who is trying for the this AMU kind of thing, he has to show up like this area is really he is interested, and this many number of publication or the research activity is there, this many number of facility is there in the university. So then they can take up and the process, and means like the upper management can deal or discuss with, among them, and readily go for the AMU kind of thing.
Okay, thank you.
Yeah, thank you.
Hello, good afternoon, sir. Sasank, sir, can
Good
I ask
afternoon.
one question?
Yes, sure, sure, sir. You proceed.
Uh, okay, thank you, sir. Thank you, Sasank, sir. Sir, I want to ask one question. Sir, can you please suggest what type of knowledge a student should require to get in VLSI companies like BTech level? So accordingly, we should train the students because we are sometimes giving some summer training in VLSI, so that accordingly we'll enhances that courses. So can you please suggest, sir, what is the basic
Yes.
things or what type of language? Like we are giving, we are training them as a Verilog SDL and Tanner and PSpice and Xilinx ISE. So can you please suggest what other type of things will train to the students so that they will fit for the industry, VLSI industry?
Okay. Okay. See, to answer your question, uh, the students, the VLSI is a very vast area, like different domain are there. So like I am coming from the digital background, and analog is there, the some kind of some tool background is there, software background is there. Like I said, the compiler, all this stuff, that is also a different domain of activity. So that depends upon like that which area the faculty member is focusing. So I can suggest in terms of the digital VLSI sector. So in digital VLSI, you can see like 60 to 70% of work in the verification domain rather than the development, because we are going with the iteration level of changes rather than some kind of new innovative. Some of the innovative work is there in the design side, but most of the thing are the iteration level in the industry. So in that sense, like I would suggest like start working on not only in the Verilog, in the aspect of like system Verilog, that what is the environment of the UVM site, or like the some kind of protocol knowledge, like that may be the AMBA protocol or simple UART or SPI. So that will be great help for them to crack the interview, because with that knowledge only they can crack this interview. Otherwise, like they'll be sitting on the it's like training or the something, so that will take some time, but if they are coming up with some knowledge in the system log UBM or some kind of protocol based knowledge, then it will be great help for them.
Okay, thank you, sir. But sir,
Yeah.
another one thing, what type of software they will use for this simulation of this system Verilog? Just like we are using Active HDL or Xilinx ISE, is there any other free tool like open source tool? Can you please suggest for system
Yeah,
Verilog?
see, there is a EDA playground is there. So there you
Yeah,
can
yeah,
write
yeah.
those. Yeah. So there you can develop your own environment. So that is a very good platform that normally I also suggest to some of the it's like um, who needs actually for this initial training, because it is very difficult for to get BCS or Cadence kind of license. So better to start with this EDA playground, so that you can create your own SBN and UVM environment. So that will be a great starting point actually.
Okay, thank you, sir. Thank you so much. Thank you, Sasank, sir.
Thank you, sir.
Sir, we do have some questions in the chat box.
Okay.
Mr. Vijay Bhaskar, he posted the questions. How would RISC-V based microcontrollers provide advantage compared to Arduino boards? This is one question. And another question, is there really any advantage of RISC-V based processors for embedded systems and IoT?
Yeah. See, this something like these are the two similar question to me. So see, Risby that I discuss. Risby is the open platform, and embedded. If we are considering on this embedded system and IoT thing, then we need a features like predefined features. So what I am not into the embedded domain, but I would say like we are including a some kind of features, and this is the particular domain of development that we are doing. So in Rixby provides us a ISA which is free first of all, and second one is that it allow us to increase or the means like develop our own ISA or we can extend it. So there it is much more useful. And those you said that window board, like I'm not aware of that one, but the thing is like there are many such like we have seen as compared to the Xilinx board itself. There are high performance board is coming means like through the Sci-Fi is providing us some kind of board, and it is highly efficient that compared to the Xilinx board itself. So I would say that efficiency is already there, but in terms of the new features addition that we can extend or we can add our own features, that is the big plus in Rixby. I hope I could answer your question, right?
Thank you, sir.
Yeah.
Thank you for the explanation. Dear audience, do we have any further queries? Uh, well, sir, I don't think our audience they got any further queries. Uh, Thank you so
Okay.
much, sir, for spending your valuable time among us. Time is very precious, and you spent your valuable time among us, delivering the informative ideas on latest research and technological developments for SOC applications. Thank you very much for being here with us. Thank you.
Thank you. Thank you, everyone.
Yeah, thank you, Dr. Bari, for your
Thank
presence
you.
here and having an informative session. Okay, thank you. We'll connect you offline.
Thank you. Thank you, everyone.
Okay, dear audience, now we are already at the end of this session, and the next session again will be held at 3:30 p.m. So we are again going to meet at 3:30 p.m. for the upcoming session by Dr. Shashank Shekhar Raut on CMOS RFIC design for SOC application. That will be session number 12. And for the session number 11, the link has been already provided in the chat box. So please do use the link and give your feedbacks. And thank you for your cooperation and support till now. Again, we will meet at 3:30. So kindly join at 3:25 p.m. Thank you all.